Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events, held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hi, I'm Hannes from a company called Access in Belgium, and I'm sitting here at GOTO Aarhus with Ole. Ole, can you introduce yourself to the audience?
Yes, so I'm Ole, working at a company called GitHub, where the world collaborates on software. I've been there for a couple of years, also doing NPM work. So GitHub acquired NPM a couple of years ago, so I've been doing work there. Previously doing work in Microsoft, also Trifork, the company doing the conference we are at right now, GOTO Aarhus, and a company called Xamarin, where we did UI testing of apps on actual devices. Very nice project. My professional work has mostly centered around automatic testing, making the experience nice for developers, but also doing lots of other stuff, DevOps and actual feature development as well.
Yeah, it's good that you mentioned testing. I saw that your first talk at the conference is about making tests better. Can you tell me what that is all about?
Yeah, it's kind of a luxury problem nowadays, I would think. So there used to be two kinds of developers, those who write tests and those who don't write tests. And lately I've only seen one of them, which is the developers that write tests, which is kind of testing has won, I guess. Maybe it's not like that everywhere, but I've only seemed to talk to people who actually write tests. And that also means your test suites are getting bigger and bigger as you write more production code. And with everything in life, when you get more and more of it, you see different problems as well. That's only natural. So at GitHub, we have looked into fixing the tests that are flaky. So I'd say the flaky test it's a little hard to define actually when you really think hard about it. But on the surface, a flaky test is one that for no apparent reason is mostly successful, but once in a while turns into a failure.
And then it messes up a test run and you have to rerun it and it takes time. And yeah,
if you have continuous integration built, then you might have lost 15 minutes of your life and you have to rerun it, which is what most people do, myself included, because then it might turn green and then you just wasted 15 minutes of your life and you just want to deploy this new feature. So yeah, weeding out these broken tests. Yeah.
Do you do that for GitHub's own tests, or are you also using all the customer data in your data set?
No, it's only for GitHub, and actually only part of GitHub's code base. Okay. So we have microservices and different projects, but we've been focusing on what we call the monolith, which is a big Ruby on Rails application. We are planning on expanding into other areas, but we got a lot of experience doing this, which is why we thought it was worth talking about. So basically taking the tests, looking at them, why are they flaky, and kind of putting them into various categories.
Right. What kind of categories would we have that make tests flaky? What can we take away as developers from your findings here?
Yeah, so we have a few categories, which the one we've seen the most is, I think it might be about timing. So most developers don't consider the fact that a test takes time. So sometimes you might read the system time in one line and later compare that to the output of a function in some some date that's being printed in a report or whatever. And sometimes in between that, just a few milliseconds have passed, then the minutes might have changed to the next minute, and then it's failing. While if you run this locally, that's very low probability of this test failing. But if you have a really huge code base with a lot of tests, then
if you have a couple of hundred tests like that, then the probability of having that happen once a week is going up, right?
Yeah, exactly. And we have other interesting things like tests leaking state into other tests, which means if you run the problematic test, that's not the one failing. It's just leaking stuff, so other tests fail, which can be really hard to
state
debug.
Being left behind in files or in a database or
both, whatever, or in memory. For example, changing the time zone. You might want to test that in one part of your code that it's robust to time zones.
But there is no proper test cleanup, or the test cleanup might have failed, and that leaks into other tests.
And you just add more stuff that you can change externally, but you forget to add the cleanup. So
that's also the type of problems that take a long time to find, right?
Yes, it is. And you have to be wary about that. So my manager told me about a thing called the completion principle, which is that stuff that's not finished causes tension, drains energy, while if you finish a task, it gives you energy. And we started out with several hundreds flaky tests. And the original idea was basically just delete all these flaky tests. That means we have a cleaner code base. It's not flaky, so people won't have to rerun the tests once in a while.
Right.
But we started looking into some of these flakes, and once you start scratching the surface, it's like opening a murder mystery book or something like that. Suddenly you want to know exactly why this flakes, and
crime scene investigation.
Exactly. Right. And I mean, all technical tasks can be like that, but now we suddenly had hundreds of them. So we did spend some time investigating, and that's why we could draw this learning, make the categories. Right. But nowadays, once we think we know mostly why our tests are failing, we try to have a more hands-off approach to it.
Right.
Basically, currently we automatically generate pull requests just deleting this test that's suddenly flaky, which seems kind of rough, but on the other hand, I mean,
does the original developer get notified?
Yes, they do.
You wrote a flaky test, we're deleting it, but if you think there's still value here, go write a better test.
Exactly, like that? So that's our approach. We create the pull request, the code owners are notified, and we let it stay for a couple of weeks, 14 days. And if nothing happens, we're going to delete that test. But the hope is, of course, that the code owners will see, okay, this either they agree with us, this is not worth keeping, because sometimes you actually have duplicate tests. You already test this code elsewhere.
Yeah, especially if you write tests on different levels. You have unit tests and integration tests and so on. And if certain scenarios are also kind of duplicated anyway. Yeah.
But amazingly often, the owning team says, "Oh yeah, that's right. I've noticed this, and I'll just make a fix." And they have much more context to actually fix the test. But it's been amazing in just watching people who get into action because somebody's interested in this nagging test they've noticed themselves before. But there's another team now, which is our team, kind of pushing them to do it. And I think mentally that means a lot for them to actually go in and fix it.
And where do you see this project going? Is it something that might get integrated into a GitHub action that we can run on our own test suites in the future? Or
so right now we have an internal tool in GitHub, but there are third-party tools out there. There's a service called BuildPulse, and Datadog also has a solution.
Mm-hmm. Yeah.
So if you're already a Datadog customer, you could implement that. So basically, the rough idea is you send a JUnit XML file to this service, and it analyzes tests, and if it finds stats about which tests are flaky, and has this gone better in the last period or worse, and you can see the worst offenders and that kind of stuff. So you can take action that way. So there are tools out there as well, apart from our built-in tools.
That's nice.
Yeah. So
what has the overall sentiment been with the developers whose tests get removed, right? Because you're writing a tool that tells them whether their tests are good or not, and takes pretty aggressive action. Is everybody on board with the mission, or do you also run into some resistance there?
Yeah, I personally was super afraid of doing this because we're like a team of 4 people, and in GitHub, I think there's around 1,500 engineers. So I felt like it was this 4 people pushing this strategy to everybody else. And I was sure people would be super angry that we would just delete some of their code. But it's been the opposite. I mean, people have reacted like, oh, great idea and nice strategy. And we haven't had any negative feedback about that. The only thing is that people say, oh, that's a good idea, but can't we fix it by doing this? And then you get kind of dragged in. Normally it's fine because the people with more context, if they take over and fix the test, that's awesome. And we can all draw learnings from that. But that's the only issue we've seen. People have been super positive, but they don't feel good about deleting the tests.
Right.
And I guess that's natural.
But that's also the result that you want, right?
Yeah.
It's like either they fix them or the tests get removed. But the end result is a better test suite.
Yeah, exactly. Either way.
But that speaks volumes about the engineering culture, I think, then at GitHub, because it's a very personal attack on your code quality. I can imagine that there's definitely engineering teams where that would not go over well.
Yeah, it could be. But I mean, as a clever person once said, test code is also code. So you have to watch out for that as well and refactor it and make sure it's readable. And maintain it, basically. So
interesting stuff. I saw that you also have another talk that I'm really looking forward to seeing tonight, which is about Commodore 64 music.
Yes.
How did that happen?
Yeah, very good question. So I just grew up in the times where, at least in Denmark, the Commodore 64 was the home computer people had. So I was a paper boy back then and earned my own money to get this computer. And
I think it's probably one of the most sold systems ever, right?
Yeah. But I guess people in other parts of the world had other systems like the Amstrad and what did we talk about? The Sinclair?
The ZX Spectrum.
Yeah, exactly. But for me and all my friends, where I come from, it was a Commodore 64. And as time passes, you just get nostalgic. I heard a Hansen Minutes podcast the other day. Scott Hanselman called Nostalgia a drug. And I think that's very true. We just like to dabble in old stuff. But when I go back to the old games, the graphics doesn't meet my expectations from memory. It's like,
you remember the experience, not the way it looked, right?
And gradually we've been accustomed to better and better graphics. But the music is still amazing, I think. I really like the 8-bit sound, which has also been coming into fashion again.
That was one of the cool things I think about the Commodore 64 is we were an IBM PC household at that time. Sound cards did not come default on that, so it could beep a little bit from the internal speaker on the main board, but that was it. And then these Commodores, I had a friend who had a Commodore, and they came with a proper sound card in it, at least for the time.
The Amiga also had sound.
And you had people doing very amazing soundtracks within the limitations of what those things could do.
Yeah, and I think it's especially impressive on the Commodore 64. I mean, it's 64 kilobytes of total addressable memory. That's not a lot. And in my research for this, I looked up the original documentation for the SID chip. They have a nice table of different frequencies you can set and what that corresponds to in nodes that we all know about.
Right.
But they have this little note in the paper saying, you shouldn't do this. This requires 192 bytes of memory. That's far too much. You can't spend all that memory on this table. So do something smarter. And I'm thinking nowadays, how many people get appraisal from their managers for saving 192 bytes?
I've only had one project in my professional life where I had to deal with like really small amounts of memory, which was an embedded chip that had 8 kilobytes of memory. If you try to get that chip to do something and make an HTTP request, for instance, that's already pushing the boundaries on what you can do.
Doing SSL.
But it also makes you appreciate the efficiency of people who work with those kinds of devices, because they go about writing code and managing memory completely different. I come from a .NET world. I just assume that memory and disk is ubiquitous and endless.
Yeah, I mean, my laptop has literally 1 million times the memory that a Commodore
64 gigs?
Yeah.
1 million? So, 1 million times.
Yeah. So even more because it's base 2. Yeah.
So that's something we stopped optimizing for at some point along the way.
Yeah, and it makes sense. I mean, I wouldn't...
It does. Especially if you're running a lot of containers on a laptop or whatever, optimizing that will cost a lot of time. Whereas getting more RAM is, compared to developer salaries, really cheap. Which is why we don't do it as efficiently anymore.
Yeah, but I think it's amazing thinking back that back then the Commodore 64 was the new awesomeness.
Right.
It was, all this memory. And
what other stuff have you run into, like diving into that Commodore 64 world? Because you're looking at it from a different angle now than you were looking at it as a kid playing the games, right?
Yeah, so it turns out it's quite interesting. So there's this online library of Commodore 64 music called the High Voltage SID Collection. The SID was the name of the sound chip back then. And you can download a big archive, and it's basically all the games you've ever had. The music is part of this library. And you can play that in various players, like VLC and other online players, and I don't know what. Then I thought, I want to be able to play this, and I want to export it into another format, MIDI format, for example, because while I like the 8-bit sound, I would also like to get kind of the information of the music, like in MIDI format. So I could, nowadays people practice the Mario tune on keyboard and other game tunes. I would like to play some of these games, the tunes from them. So I thought, how hard can it be? It's in one format, I want to convert it to another format. But it turns out this SID format includes executable code. So what you do is you actually run a Commodore 64 emulator, which pokes the addresses in the SID chip to make it play the sounds just like on a real Commodore 64.
Right.
So you can take these SID files and actually run them on a Commodore 64.
Does that mean that the SID files also have control structures in them?
Yes. I mean, it's just machine code.
Right.
So that was the biggest hurdle. Getting
like getting that to MIDI, which is just like a timeline-based sequence of notes and sounds, right? And
but it makes sense because back then musicians were also programmers. When you had to write a soundtrack for a game, you also had to supply the machine code for playing.
Right.
So on every frame, so 50 times a second in Europe and 60 times a second in the United States and Japan, it would get a callback and do something and poke the address.
So that kept the whole thing in sync with the refresh rates on the screens.
Which also means if you played the same game in the United States, the music would be a tiny bit faster.
All right. Yeah.
And also the pitch would change a little bit because the frequency of the frequency generator would be changed.
Is that something you can now just solve in the emulators as well? Can you emulate it in EU and in US?
Yeah, that's not a big problem. That's basically changing the frequency and calling it more or less often. That's been quite fun, kind of doing parts of a Commodore 64 emulator just to get out these sounds from the old games. It's been super fun. A little more digging than I would have expected at first, but super fun.
A little bit of technological archaeology. So
exactly.
Looking at what people were doing 30, 40 years ago, and how the problems that they had to deal with, and look at maybe the simplicity of what they were doing, right?
Yeah.
What do you think in the future is going to happen if we look at if people do the same for the code that we write today?
Yeah, I don't know. So, people looking back to 2022, like, oh, the simple times we only use 7 different programming languages for this solution and only 3 different cloud databases and I don't know what. I hope we'll keep it simple the next 20 years. But it's quite amazing looking back at what used to be the state of the art.
That goes against the common trend at the moment, keeping things simple, right?
True.
We are overcomplicating our lives with a lot of things in a lot of ways. I mainly blame conference speakers for that, and maybe myself included. If you tell a story about certain technology, it solves a certain problem, and people want to use your solution, but they might not have the same problem. So they might look at Netflix and Spotify and how they do things, but they don't have the problems at that scale.
Yeah, exactly. Simon Brown addressed this very succinctly yesterday, just saying, don't.
Keep it as simple as possible. I think my Twitter bio says something that I'm a monolith advocate, and I still stand by it.
And you're what?
A monolith advocate.
Yeah.
So I would say, like, if you're building something new and you don't even know where it's going to go, like, build something simple that you can push out quick. That doesn't mean write crap code. I mean, that's a completely different thing. But, like, construct the code well so that you already implement the dotted lines. Like, we might be able to cut here in the future, but we're still going to all deploy it as one unit of deployment and ship it and see what users do with it.
Yeah, exactly. Yeah, I'm also a big fan of that. I like monoliths as well. It's like, for some reason, a lot of people like microservices, but I've never really understood why. I mean, if you have a mature system and you have something that's really separate from everything else, well, sure, split it out. But people who do that from the beginning, they're just going to have a lot of issues refactoring across the network, basically.
Yeah, like moving something around becomes a lot harder, right? If you have separate services. Whereas if it's one code base, you just move.
And another point people forget sometimes is that you can deploy a monolith as microservices. You can just enable certain endpoints in one deployment. You can scale that up and down as you want to, depending on the traffic. But
that's what Stack Overflow did for a long time, right?
Nice.
They called it a scalable monolith or something like that, where basically every service was the same code base, but like in orchestration, they changed what all the units were doing. It was very interesting. They have a very nice engineering blog about how they did things. And they basically were on ASP.NET with SQL Server for a very, very, very long time, like really boring technology, pushing that to the absolute limits of what's possible. I think we should take inspiration from all sides of those stories and look at what our problems are before we start applying these techniques, right?
Yeah, because you can separate concerns within a monolith. I mean, programming languages have had those facilities for many, many years.
Of course. Like patterns like solid and maybe mediator patterns where you separate some of the services inside the same code base, right? You said that you were working on the monolith at GitHub. What does that look like? Is that something you can talk about?
Yeah, in some parts at least, it's basically a Rails application. So we do have microservices as well in GitHub, but mostly for big issues. It's not like every time we do a new functionality, it has to go to a microservice, but sometimes it makes sense. But the core functionality of GitHub is in this monolith, which is Rails, and we keep on the edge of Rails, which means that we can contribute back to Rails. I mean, the monolith in GitHub is not open source, but we still contribute to a lot of open source projects. We have core contributors for both Ruby and Rails in GitHub.
Oh, that's nice.
Yeah, so we have people we can consult with if we have issues with Rails. But mostly, all people are super happy that we are ahead of the curve there. I think some years ago, it's been discussed publicly as well. We were very much behind on an unsupported version of Rails, but then some people said this is not the way to do it, and it got upgraded, and now we are continually.
And after that, those people moved to the GitHub team, or they were already there?
I think they were already there. That's before my time, so I don't know any specifics. Right. But there are people who continuously upgrade Rails and keep us.
How is that something you think that GitHub is doing well, like contributing back not only to Rails but to a lot of open source?
Yeah, definitely. Yeah, I think so.
Because that's I think one of the things that we see in the open source world is there's not a lot of contributions coming back, both in terms of funding and in terms of code, to a lot of open source maintainers. They just get a lot of complaints when stuff doesn't do what people expect it to do, right?
Yeah, and there have been recent incidents about what can an open source maintainer do with his or her own projects, and what can enterprises expect when they just grab some free project. Right. So there's a lot of good discussion there, and I don't have a good response to that.
No, but if we want to keep open source maintainable, I think as an industry we're gonna have to rethink how we work with that.
Yeah,
I think a lot of companies could do more instead of just being the consumer, but also giving back. So I'm happy to hear that at GitHub at least there is some of that going on, which is great. Makes open source a little bit more maintainable.
Yeah, it's interesting because I think a company just grabbing a free product, there are limits to what they can expect in support from taking a free product, of course. On the other hand, if you're an open source maintainer, you put stuff out there for free, there are limits to what you can expect from companies using your product. So it's in both ways, it's complex. Because we all want to do good, but we have limited resources and limited time.
And if most of your experience is maintaining something or toxic because people are complaining, but they're not paying you for it.
Yeah, exactly.
Those projects might get orphaned, right?
Yeah, and often you think, this open source project, a lot of companies are using it. It must be well supported, but it turns out it's
like one person.
Yeah.
And they might drop off the grid.
Yeah, exactly. And what to do then?
I think that pretty much brings us back to where we started at GitHub. I want to thank you so much for this talk today.
It's been a pleasure.
A lot of interesting stuff there, and I look forward to the Commodore 64 talk.
So am I. I mean, normally I'm super nervous before a talk, but this I'm just really looking forward to it. It's going to be nice and lots of music, and you won't learn a single useful thing. I promise you that.
That is okay. I always love those talks where we are taken out of our comfort zone. I've seen talks that had nothing to do with software engineering, that had zero applicable knowledge. And I enjoyed every minute of them just because the speaker was passionate about what they were speaking about. I think that's a very great way to end GOTO Aarhus tonight. So I'll be there.
Yeah, awesome.
So thank you very much.
Yeah, likewise.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.